Runtime reproducibility in Python.
Woo! Okay. So I think we have spent quite some time talking about reproducibility in general, but I feel it's a bit targeting like what happens before we get something we can install, like the build aspect of it. And then our end users are a bit forgotten in this discussion. So this talk, we're going to talk about what happens when you want to run the thing, not just build the thing. So maybe it's going to be a bit more high level. We're not going to talk about solvers too much, a little bit. So yeah, let's go to it. Who am I? I'm Jaime. I work for Quantsite. And yeah, I'm mostly involved with conda stuff, conda forge, conda, Mamba solver, Mamba, conda, Mamba, Mamba, conda, Rattler, conda, Mamba. If that's confusing, it's exactly how it is. I've been also doing some work for Napari in the application delivery parts, like building installers and figuring out how to have a plugin ecosystem. And as you might have seen, I will do some puns, so I'm going to do all of them right now. So this conference is packed with great topics, and I hope we can reproduce this experience in the coming years. Thank you all for organizing everything and all the collaborators. And the other person, you don't have to laugh, it's okay. The other person in my slide is Pavitra. She's a dev in Quantsite as well, and she's involved with Conda Store, Nebari, okay. So I want to thank her because of the help with the preparation of the slides and the initial proposal. So, who has said this? With possibly shrugged shoulders. But who has thought about that sentence? Because it packs a lot of things in, what, 1, 2, 3, 4, 5 words. So let's talk from the beginning. It. What is it? Is it an application? Is it a script, a notebook, a library? We're not going to cover libraries today. But so when we want to run something, it's because it produces a result. Libraries, the only result that might produce is frustration while we are developing them, right? So let's focus on that part today now. Then, works. What is working? And that's where the reproducibility part comes in. So I've come up with this poor definition that we're going to use for the rest of the talk. Repeated installation and execution steps that provide a consistently correct result. Quite clear, I think. I like it at least. And then machine. Machine is like what? A vague definition of hardware, OS, kernel, libraries, executable binaries. The time of the day where you executed that, I don't know, maybe if you had coffee or not, that plays a big role in reproducibility. Like humans are famously prone to error. So this is going to be the takeaway today. Reproducibility at runtime and everywhere has to be proactive. We cannot think about reproducibility when it's too late because we didn't reproduce it. So you have to take this into account early on. It cannot be an afterthought, okay? Let's model it early. We can do it in different ways, but I'm going to borrow some concepts from threat modeling to help us put some vocabulary in this discussion. 4 steps. First one, define objectives. What do you want to mean by working on my machine? Maybe it's my machine only. It's my machine in 2 years. It's my coworker's machine, or all the machines in my organization, maybe all the deployments of my application, all computers in the world. For that, you need some sort of virus component, but we're not going to talk about it today. Define your objectives. Think about what you mean by having reproducibility. Next, enumerate the components of your supply chain. Let's put it in 2 groups, the ones you own and the ones you don't. The ones you own, you have to be very obsessive about it. Annotate everything. The script, the notebook, library, application. Use version control. I don't have to tell you that. But also annotate things about your hardware or the data you need to run your applications or script. Okay? Everything you control, you need to know. Inventory. Then you also have to know about the things you cannot control or cannot afford to control, or it makes no sense because it's too expensive or just too costly. Your dependencies, the things that produce your dependencies, the infrastructure that provides your dependencies. Annotate it. Next, this is my favorite part. What can go wrong in an OCD way? So enumerate your threads. What happens if PyPI, hypothetically, is hacked, and then all the files that I'm using in my CI or do not work? Well, do you want to model against that? Do you want to control that threat? Up to you. Evaluate the risk. What is the likelihood of such a thing happening, and what is the impact to your objectives if that would happen? Finally, once you have established an accepted level of risk, how comfortable you are with delegating some part of your supply chain, what can go wrong, and then what can I afford to care about? Study how you can apply those measures and do as necessary. That's the theoretical part. Now let's see how this works in the real world. Searched a curious intersection of two technologies, Python and the web, because it's always cool to see your thing running in all the computers, and sometimes we use servers to do so. Django, Flask, or something, or more recently, Streamlit is super cool. I love it, and you can create something very quickly. It's kind of addictive. So I searched for a web application on Streamlit and found one that uses Vix, data frame that operates out of memory and is super cool, and also such a challenge for packaging because the dependency tree of Vix is huge. I've been using that while testing the limit iterations in Conda. Is one good benchmarker. So I saw this blog post, and it's like, wow, I want to see if I can reproduce that on my machine. Let's see if it works today, because the blog post was 1 year old from a project that is still maintained. I went to the linked website, and it's down. DNS, it was always DNS. Something Cloudflare, I don't know, but I couldn't see that GIF or GIF or animation that you're seeing on screen. OK, fine, it's OK, because the blog post had the decency of linking to a repository in GitHub, which was still online, and even had a requirements text. So, OK, it's not too bad. We're going to be able to do this, although with some effort. The requirements text contained those versions there. Some Vix version, Streamlit, NumPy, Plotly, Word, Cloud. So I copied those things, knowing there are probably pip requirements, but I'm more involved with Conda stuff these days, so I assumed maybe they work for Conda as well. And they share the same names, and the versions were there, so it worked, with the exception of one typo. There's no such thing as Word Cloud, only Word Cloud, so I have to remove that L there. And then you get this beautiful list of dependencies. Those, how many? 6 packages actually mean that huge tree over there. That's in one word, underspecified. It doesn't even mention what Python version you need for this. So we can only assume. And then you start thinking about it, it's like, oh my God, there's no OS listed, or even the architecture. So do you have to make educated guesses to reproduce this experiment? That's what I had to do to install it and run it. So what happened there? There was an exercise of very optimistic trust and delegation. They were fine with listing requirements.txt, and then that should be enough to put it online. And it was. But there were people in that, or components in that supply chain, making decisions for them. It was running on Streamlit Cloud, but the domain is now down. So one component that failed. The dependencies rely on PyPI or Anaconda, in this case, being online. Maybe this is not true, fingers crossed. In 10 years, I don't know. Python version was not specified, as we discussed. Same with the platform OS. I can only assume that Streamlit these days runs VMs using Ubuntu 2204. Who knows? So how can we make it better? I think Platinum mentioned this in this funnel with the 6 levels. So we're going to take a trip from the bottom to the top of that trust-driven gradient descent. If I trust my users or delegate a lot, I can just be fine with which packages I need and the Python interpreter. Maybe that's enough for immediate needs. You can do this with conda and environment YAML. This is very common and usually where people stop. And then, well, maybe you're even mentioning in which OS you have to run this. And yeah, if you're an X fan, then you have less problems now, but only if you're on Linux. No shade. Then, if you are a bit more aware of the problems of your supply chain, then maybe you have even a log file with all the packages that I showed that big list before, and that's better. So nice. Conda log, conda list explicit will give you that. Pixie also does it. But you can also do it with pip freeze and just state in your best OS and delegate the interpreter to your system. That's OK as well. If you don't trust the internet or the repository, artifactories, or whatever, then you can be a bit more paranoid and pack all the downloaded stuff in a tarball with some scripts or logic to install that simply. So you don't even need to have conda on the target machine or pip on the target machine. Do it. If you are even more paranoid, you can bundle the system libraries too with the contents of number 3 plus whatever you need to put in a container. You are leaving the kernel behind. OK, let's put it in a VM with all the above. No? You get the memo at some point. You might even think of shipping your machine with written ROMs and whatever. A note of caution for the paranoid people, legal stuff. Okay? Every time you're distributing something, like an artifact, not just the instructions to install it, but the actual thing, the licenses of those projects might require you to bundle the license itself. If you are not, you're technically incurring in some kind of violation, and your company might not be too happy about that, or whatever. But check licenses. They're important. When you're vendoring things, that's true as well. So always pack your licenses. Next. This is assuming that you have a final product and you're shipping and you just want people to use it, and that's super happy. But during the exploratory phase of building that dashboard, what happened? If there's a team and you have to share your progress with your supervisor, or there's a code review, I want to install it too. It works on CI, but I cannot reproduce it on my machine. What do I need? Data science, right? So it has several challenges in this world, especially when you're using multiple languages and packaging ecosystems at the same time, because machine learning and all this AI stuff, they move very fast, they break all the things, and the practitioners do the same with their environments. So IT in your organization would prefer to retain some control, but then I cannot explore this new algorithm because I need the new PyTorch. So yeah, it's basically there's a tension between being reasonably reproducible during the exploratory phase and then actually working. So how do we come up? Can we come up? Sorry, English. How can we come up with workflows that make reproducibility easier? And this is the part of the talk. Conda store. Introducing conda store. So it's just a tool to build on top of the conda ecosystem to manage environments and do it for teams more than individuals. The design goals are two, mainly. It should be easy to use while ensuring that you're doing things in a reproducible way. So it tries to hit that compromise point between these two tensions we're considering. The UI has been designed so the practitioners do not fall into the traps of not specifying their dependencies enough. So for example, there will be like a very visual hint of telling which version of the package you need. So you have to be a bit more strict about what things you need. And it will produce fully specified environments once you have that down. There are version controls. So every time you modify an environment, you have a checkpoint with a log file to go back. And these are shareable as well, so you can actually tell your teammates, yeah, no, I was using the one from yesterday. Try with that one, it should work. And if you have a large group and requirements in your organization, then there's mechanisms in there, so you can require specific practices, like only use internal mirrors, do not use this channel. You always have to have this package in your environment because it provides certain assurances, or we don't want to use anything that has GPL in it, things like that. It has reproducibility in the design of the workflow. So again, you will always have a fully specified environment after you specify your inputs. Those environment YAMLs with 4 lines are not environments. They're just an input to a solver that depends on repo data that changes daily. And even retroactively, the thing that solved yesterday might not solve today. These artifacts of the output of the solver are produced in a multi-platform way, thanks in part to funding provided by the Sovereign Tech Fund. Thank you. And we're working on that. But today, you can fully use it in Linux environments. You will have Docker containers, Larables with all the conda packages, or you can just render to your file system directly, even if it's a shared unit or something. What else can we do that? I mean, you could ship a VM, and that starts getting into the paranoid level, right? So the workflow provides reproducibility as part of it. It's not an afterthought. It's not a thing you have to worry about. It's part of how you work. How much further do you need to go after having a reproducible installation? Well, that's on your code. There are things that we cannot control from the packaging standpoint. The kernel version of your machine, maybe that's too much. What hardware were you using when you run that? Maybe it's only one type of GPU that successfully builds your models because of the allocated RAM or something like that. The emphasis. Find a workflow that enables reproducibility as part of it is not an extra step, should be integral part of how you work. So we're finishing already. Key takeaways, if you didn't hear anything and you need to pretend later, like, hey, no, that was super nice, this guy. Like, okay, this is the key points, okay? Analyze your supply chain and enumerate components and threads to the obsessive point of view, and then see which things you can worry about. Capture all the runtime details that you cannot control after that hardware, OS, kernel drivers, in things that are stochastic, randomness, like your seeds or determinism in your operators, please. And again, version control, date and time, all those things are important if at some point you need to do some post-mortem because the model doesn't run. There are some tools, if you're using notebooks, that help a lot in this, like Watermark, that will print a cell with some stuff that might be useful when you are comparing why this thing has a different result, even if it is installed correctly. And test it. It really makes no sense to have all these assurances in your workflow if then they're insufficient for your needs. Assuming that you have good repro when you don't is even worse than having none. So yeah, this is the same as a backup. And I think that's everything, no? Yeah, look, well, nice. Thank you for your attention. And yeah, let me know if there are any questions or time.
We have time for questions. But any hands? I see one.
There, yeah.
Hello, can you elaborate any more on the Sovereign Tech Fund and the process of acquiring that and what results it had on the project?
Not really. I mean, I can't tell you about the project we have, the things we applied for. But if you want to talk about how the process works, I think Abigail is, or this was in the conference, if you need more details. Okay. So our project is going to be about bringing multi-platform support to Conda store, mostly, while also providing the tools we depend on to generate the artifacts you see on the screen, like the Docker images and so on, with some extra maintenance. These are community projects that have not been maintained in a while, so they're in live support. And we would like to streamline those because they all share common building blocks. You have to solve the environment every time you call these tools. So we would like to have like a unified solver step, and then we just pass the log file to these like renderers that will create the Docker images, the conda packs, and so on.
Any more questions?
So it sounds like it's not implemented yet, so maybe it's too early to know. But when you talk about having a multi-platform solution, is the idea to solve once, potentially across multiple real dependency trees, and maintain one pre-solved solution or lock file, or would the intention be to have a lock file per platform, something closer to like a pip freeze or a conda explicit list today?
These days, you can do it in both ways. So the naive approach without extra tooling with conda itself is to run the solves for each platform and annotate their frozen requirements separately. But there's another tool called conda lock that does this for you, and there's a unified YAML format that will, in a single file, contain all the platforms. It doesn't try to optimize the platform varieties, so they are as similar as possible. They just run the solve for each platform, but at the same time with the same repo data. So at least there's some control of these differences that you could find if you did it manually across different times. And I believe this is what Pixie does as well.
Any more questions? I see one more hand. This is the last one.
Yeah, because after the third one, I start charging extra. Yeah.
One, I really liked your talk. I think it was funny. I really appreciated that. But two, I was really interested. You mentioned runtime details you can't control. You mentioned OS kernel, maybe kernel version. I'm interested. Are you saying that those are represented in the conda store tool now? Like as in this machine compatibility stuff that's not recorded in pip is what is in conda store, or are you? I guess I'm interested in, is that information used for compatibility? And just because it's interesting, because pip doesn't, of course, have some of the stuff that you kind of mentioned, and I'm interested in seeing whether other places could take advantage of any of that format. I'm interested when you said runtime details. I'm interested in how that's represented in conda store is all because I want to know more about that. Mm-hmm. Sorry, thank you.
Thanks. So we have to understand how conda store can help you and till when, till what point in your workflow. Currently, it stops at the moment of providing you with the build instructions for your environment. Once you start running Python or whatever, you are on your own, right? But the workflow of I run this notebook and then I have an error, why, if it worked yesterday? At that point, you can go back to environment definition, but it doesn't inject any type of extra runtime checks when you are running your own. You are on your own. But you could hack things with conda packages. For example, I'm thinking if you want to make sure that every execution is logged or something, whatever, you could have your own Python package that forces every subprocess to disk or something like that. But yeah, at that point, you have to get creative. You're just providing you with the tools to make that happen across a team.
Awesome. Thank you, Jaime.
Thank you all.